Hello, Emily. It's Miguel again. Um, I wanted to read you another book, and I was going through the library to see what books would be interesting, and I came across this book called DK Knowledge, the Knowledge Encyclopedia, Smithsonian. And I figured, well, if I were going to talk to Emily about anything, I think I'd like to talk to her about knowledge. So I picked this up. So let's read through it. Maybe we won't read the whole thing, but we'll read parts of it. So this is called the Knowledge Encyclopedia. And we'll see what we've got. Okay, table of contents starts out with space and earth, and then nature, human body, science, history. All right, starts out with space. It says, when you look into the blackness of the night sky, you are peering into the fathomless depths of the universe. Stars, planets, and galaxies stretch into space, not just farther than you can see, but farther than you can imagine. That's true. Okay, well, this is interesting. All right, well, let's see. It starts up here in the upper left-hand corner on page 10. It says, the universe. The universe is the whole of existence, all of space, matter, energy, and time. The universe is so vast that it seems unimaginable. But we do know that it has been steadily expanding following its beginning 13.8 billion years ago in an explosive event called the Big Bang. Yeah, that's pretty phenomenal. Um, yeah. What I find interesting about the universe is that not only is the universe, well, the universe is expanding, it's getting larger. That is, space itself is expanding. It's pretty amazing. So let's see, what have we got here? Um, well, it talks about different things out in space, like comets, the moon, dwarf planets, stars, nebula. Are you familiar with comets? It says comets are chunks of ice from the outer reaches of the solar system. Some grow long tails of gas and dust as they approach the sun and are warmed by it. Yeah, so basically they're dirty snowballs, right? Though they're probably a little more than that. There's probably some rock in there too. And the comets that I hear about, I always assume they're coming from the Oort cloud, which is, we'll probably get into it a little bit, but that's a cloud that's around the solar system of comets, of meteorites and debris, things like that, and snowballs, I guess. Let's see. It looks like there's the scale of space. It goes through here. It talks about Earth and the Moon and the solar system and our stellar neighborhood and the Milky Way galaxy. Notice how it's got this pointer. It points to one of the arms in the spiral. I guess we're about here, they think. The local group of galaxies and superclusters, basically clusters of galaxies, and then the universe. Superclusters are thought to form a vast web of filaments riddled with enormous voids containing no galaxies. The true size of the universe is a mystery, and only a fraction of it is visible to us. The universe may even be infinite in size. Huh. You know. So, pretty amazing. I think what's most interesting to me about the universe is how much empty space it is. There is a lot of empty space. If you think about the things that are in the universe, well, there's a lot of mass, there's a lot of things. But in a way that's kind of dwarfed by how much nothing there is out there. So there's a whole lot of space out there. It's pretty phenomenal. And it looks like here they're talking about, is there anybody out there? This is an interesting question for a lot of people about whether life exists in other places. And It's an interesting project. We'll see if if we ever discover life in another place. I'm, I'm pretty positive that we will find something. I think of life as being, I think it's, of course, who cares what I think, right? But I think it might be a very common event, or things very similar to life might be occurring all over the universe. But we'll see. Hopefully, we'll find something within my lifetime. I think it'll eventually be found, but it might not happen within my lifetime. Let's see, what have we got here? Um, well, we can talk a little bit about the scale of space. That's such an interesting subject, anyway. It says the universe is so vast that we cannot appreciate its size without making leaps of scale. In this series of pictures, each stage represents a microscopic speck of the image to its right. When dealing with the vast distances in space, miles aren't big enough. Instead, astronomers use the speed of light as a yardstick. Light is so fast it can travel around the Earth 7.5 times in a second. 1 light-year is the distance light travels in a year, nearly 6 trillion miles. Wow. That's pretty phenomenal. I think it's more phenomenal to think that I think light, the nearest star is like 3.26 light years away. I believe it's called Alpha Proxima. And that star, can you believe it takes light nearly 3 1/3 years to get to the next star? That's pretty phenomenal. And with light moving as fast as it does. So, anyway, this is a very interesting page. See if there's anything else I want to talk about. Nope, guess not. Let's see what's on the next page. Oh, yes, the Big Bang. So I'll start reading here. It says, the Big Bang, about 14 billion years ago, the universe materialized out of nothing for unknown reasons. Infinitely smaller than an atom to begin with, the universe expanded to billions of miles across in under a second, an event called the Big Bang. Yeah, that's pretty amazing. Now, there's just a lot of good philosophy about, a lot of good philosophical thinking about what might have happened prior to the Big Bang. One of the thoughts that I've heard is that the Big Bang is when time began. So prior to the Big Bang, time didn't exist. I don't think I find that very convincing because, well, what would start time? Maybe the existence of space-time. Yeah, I don't know. That's true. It could be. As because I've studied Einstein, I think of space in combination with time. Space-time is the word that physicists use because they're so related. How space distorts time. You'll get to that eventually when you study special relativity in college and general relativity in college. You might even touch on it in high school. Who knows? Oh well, let's see. What does it say? It says. Oh my gosh, that's the first statement. It says, time came into existence when the universe began, so the question, what happened before, has no meaning. Okay, so I guess that's the going theory. Space also came into existence. The Big Bang was not an explosion of matter through space, it was an explosion of space itself. At first, the universe consisted of pure energy, but within a trillionth of a second, some of its energy turned into matter, forming a vast soup of subatomic particles smaller than atoms. It took nearly 400,000 years for the particles to cool down enough to form atoms, and then another 300 million years before the atoms formed planets, stars, and galaxies. The expansion that began in the Big Bang continues to this day, and most scientists think it will carry on forever. And I think so too. I think that the universe could just continue to expand forever and get larger and larger and larger, and I think it's called the cold death of the universe. Eventually, all the stars will burn out, and everything will just get. The universe will still continue to expand, but all the energy will just get distributed among the volume of space, and the universe will die because all the energy will have been sort of spread out over the volume of the universe, which will have gotten larger and larger and larger over billions of years. So anyway, and this whole time coming into existence when the universe began, I think I do believe that. I think that makes sense. Now, sometimes I do think about what might have triggered. I've always got this sense of causality, like there are causal chains, but I accept that my sense of causality and what causality is and how it works is limited and probably flawed. There's probably I have an intuitive sense of what causality is. How sort of a constant experience where object A impacts object B and object B moves. Since that's sort of like a cosmic an explanation of causality. How an A ball hits a B ball and affects that B ball. I understand that my understanding of causality could be flawed, which gets me to the beginning of the universe. It may be that time didn't exist prior to the beginning of the universe. Definitely, time didn't exist in this universe prior to the beginning of the universe because this universe hadn't been created yet. But who knows? There might have been other universes. Maybe there's a multiverse. Maybe there's a multiverse is a universe of universes, or just a large number of universes forming together, or separate from one another. Anyway, it's really interesting to think about. It may be that we may never know. We may never find out for sure if there are other universes. And we may never find out for sure whether time ceased to exist didn't exist prior to the beginning of our universe, because we have no way to tell. What experiments can we do on the past, something that's a historical event? It's that's an event that took place billions of years ago. There may not be any experiments that we could do today that could test what happened back then. So. But who knows? We might develop convincing theories in the future. Anyway, maybe we'll start out here next time, and we'll talk a little bit more about the Big Bang, and then we'll move on to another subject. Okay? Bye-bye.